that neither terminates nor repeats. It's irrational if it can be written as a decimal that neither terminates nor repeats. That means it just keeps going on and on and on. So if you put in the square root of 2 into your calculator, let's just do that for the heck of it. Go ahead and see what it looks like. Go to our calculator. We'll clear that out. We're going to put in, hopefully you can see that. We're going to do square roots, so we're going to do second. Square root, we're going to put 2 in there. Notice I went to second first. That gave me the square root sign, and then I hit that. I'm going to push it out of that so I can get the answer, and hit enter. And although it looks like it ends, it just keeps going on and on and on. And that would be an irrational number. Let's do this the book. All right, can you guys see the book again?
Yes.
Thank you. Thank you very much. All right, so let's just go to the first problem. Simplify each radical. Well, the square root of 40 is the square root of 4 times the square root of 10. It can be written as you can see it in the first line here. You can split it apart. That way you get the square root, so it becomes a 4. So you look for the highest square root you can find in 40, and that, of course, it is 4. It gives you 2 times square root of 10. The square root of 200 is going to be the square root of 100 times 2. That's going to give you 10 times square root of 2. That's kind of how they want you to solve these. The square root of 26 is kind of like the square root of 2 times square root of 13. You really can't do anything. So I would just leave the square root of 26. And that's that one. Number 2. All they're showing you is in mathematics, the square root of anything that's multiplied together can be broken apart. So as long as it's multiplied. But now if it's addition, a plus b, you can't put the square root of a and then the square root of b. It's different. It's not the same. So for example, if you take the square root of 9 is 3, the square root of 16 is 4, 3 and 4 is 7. But if you add them, you get 5. So you can see they're not the same. Kind of a little trick one right here. Just showing you that. The product is easy. 6 times 2 to the square root of 18. Excuse me, 12. I thought that was a 3. It's 12 is going to be the square root of 4 times the square root of 3, so it's 2 times the square root of 3. Again, you're looking for square roots in 12. The largest square root in 12 is 4, multiplied by 3. They give you another one here. Let's see. 5 times 20 to the square root of 100. Of course, is 10. Easy enough. Go to the next one. The quotient rule. All they're showing you is that you can write a square root. Well, let me just show you. I mean, you probably saw it already, but it's pretty simple. But a lot of people get nervous when they see things like this. So if I write the square root of 9 over 25, It's the same thing as saying the square root of 9 over the square root of 25 like this, which is equal, of course, to 3/5. So you can split them apart like that. All right, let's go to the next part. So that's what they're going to do. So, can you all see it? Is it blurry? It's good. So the square root of 27 over the square.
Professor Wickman?
Yes.
Sorry, I'm a bit late. I'm running late from work. It's Rosie.
Rosie.
Yes.
Rosie Smith.
No, it's Rosie Ibarra.
Thank you for checking in. Thank you, Rosie. I got you now.
Sorry about that. Thank you.
All right. So the thing about A is this. It can be broken down differently than what they even show you. Let me show you how it really looks. It really looks like this. The square root of 27 over the square root of 3 really equals the square root of 3 times the square root of 9 over the square root of 3. And you can cancel, which then gives you the square root of 9, which is 3. They don't really show you all this step or maybe explain it, but you can break 27 down in such a way you can cancel from the bottom. And you should. That way, you go from a fraction to a whole number. The same thing with the square root of 60. You know that there could be a square root of 5. 5 goes to 60 is 12 times, so that's how you end up with that. Is there a question about any of this? This is kind of lots easier than the logic stuff. Okay. You can add them as long as you have the same root. This is like saying you have 6 apples plus 8 apples plus 5 apples, you get 19 apples. But instead of apples, they're square roots of 3. Same thing with subtraction. You're going to end up with a negative 4 square roots of 10. But it's like, as long as they have the same square root. Now, they can try to make these things look tricky. So the square root of 12, in fact, is, let's see if they show it, is square root of 4 times square root of 3, which gives you 8 square roots of 3. So that's that one. Then you have 3 square roots of 8, which again, that's 4 and 2, which gives you 6 square roots of 2. And 5 is 32, which is 4 times 8. Or 16 times 2. And so they boil them down. They look at all these 3 square roots and try to find the highest square root that's in each of them and break them down so you now have 8 square roots of 3, which that was converting the 4 and the 12. The 6 square roots of 2, which is the 3 and the 8. And 20 square roots of 2, which was the 5 and 32. And then you put them in with their proper signs. 8 minus this plus this. Now the only thing you can add is the square roots, or combine. 20 minus 6 gives you 14, and so that's your final answer. 8 square roots of 3 plus 14 square roots of 2. Now, let me show you one thing about that, though. If you put that in a calculator, it can be different. Let me get my little notebook here. So what we're going to do is in our calculator, they give you the final answer is 8 square roots of 3 plus 14 square roots of 2. Let's see what our calculator says about that. So let's clear this out and let's add it. We said 8 square roots of 3. We'll push it out of there. And I want to add 14 square roots of 2. So hit 14. Square root, I got to take second, which is going to give me that square root sign right there. I'm going to put in 2. Push it out and add it. Notice I get 33.655, so it can add them for me. Let's see if it'll give me a fraction. Second, fraction, math, enter, and it won't. So it does not convert into a fraction. It means it kind of goes on and on and on. But you can add them and you'll get a decimal. And if I said I wanted the answer to the nearest hundredths, it would be 33.66. All right. That one is quick. Back to the book. Now, the rules in math are you can never have a radical in the denominator. That's the rule. So if you're 18 over square root of 3, what you have to do to rationalize it, you got to multiply the bottom by the same thing. As shown here in the solution. Anytime you multiply a radical by the same radical, you get whatever's inside is 3. So I know they get the square root of 9, but it's always going to be whatever it is. So let me give you my own quick problem. We've already seen that one. Based on what I said, if you have, let's say 5 over the square root of 2, you know you must get rid of the square root in the denominator. So you're going to multiply the bottom by the square root of 2. And whatever you do the bottom, you got to do the top. Now, you could write square root of 2 times square root of 2 as the square root of 4, which means it's 2. But as long as they're the same thing, you're just going to get 2. And the top becomes 5 square roots of 2. That's a 2. Should be this. 5 square root of 2 like this over 2.